In this video, we're going to learn how to create an Excel calculator that will do confidence intervals for two independent means, where of course we don't know the population standard deviation, and we're going to assume they're unequal. Okay, as always, the stuff in yellow is the stuff that you will have to type in manually. It's what you'll be given from the questions, and then everything else will be auto-populated from the calculator once we create it. So the version on the right would be, you have a question that they give you the details of the two samples. They tell you the sizes, the means, and the standard deviations. And the example on the left is they just give you the raw data, and you have to run that stuff yourself. So the first thing we have to do is the degrees of freedom. And this is that same terribly complex formula that we used when we did the degrees of freedom for two means in the hypothesis test. Makes sense. You know, if we're doing a hypothesis test versus a confidence interval, it should be the exact same computation, and it is. So what I would recommend is make sure that, go watch the hypothesis test video if you haven't, and then you can just copy and paste that one in here as long as everything is in the same spot. And what I mean is, you see how it goes? Size, mean, standard deviation, size, mean, standard deviation, and then degrees of freedom. If you look at hypothesis testing, for two of them, it does the same thing. It goes size, mean, standard deviation, size, mean, standard deviation, and then degrees of freedom. So if you have this one already calculated, you can copy it and paste it, and because it's in the same relative position to where all the same numbers are going to be, i.e. sample one size and the mean of sample one, and so on and so forth, it will basically still calculate the same thing correctly. So you could do a copy and paste. The other thing you can do is, try and type it in yourself and learn some long kind of formula coding in this thing, which is an admirable thing to try. I'm not going to waste time trying to recreate it. So instead, I'm going to copy and paste it here for you. And then if you want to, you can just basically rewrite this, or like I said, if you've done it in the other one, you can copy and paste it from the other one. Either way. Okay, the rest is pretty easy, because alpha is always equal to 1 minus our confidence level. The T critical level is also the same computation for all of our Excel calculators, and it equals the confidence level plus 1/2 of our alpha, so alpha divided by 2. And that's because we're trying to find that T critical so that we can do get this value, right? Find the T value that comes associated with having that percentage of the area below it. And that's what we're going to do next, right? That's the equals the T inverse function. This is our probability, comma, our degrees of freedom is that terribly complex thing that we just copied and put up there. Then our standard of error. We're basically recreating this portion of this display, right? That's our margin of error, or our standard error. So this is going to equal that T thing that we just found times the square root. And it's the square root of this stuff, right? So it's going to be the square root of the first standard deviation squared, squared, divided by the first sample size, plus the second standard deviation squared, divided by the second sample size. That's going to give us our margin of error of 4 point something. Then the lower confidence and upper, they're the same in all of our calculators. They simply just equal whatever our measurement that we're dealing with is for this particular thing, the thing that we're building around. In this case, we're building around the difference of means. So it's going to be mean 1 minus mean 2 minus the margin of error, and then so on and so forth. So it's going to equal mean 1 minus mean 2. That's kind of our single point estimate that we're building off of. And then we're going to subtract the margin of error. And then this one is going to equal mean 1 minus mean 2 plus the margin of error. Okay. Now to do these, the bottom is exactly the same. As far as everything, is computed the same way. Everything is set up in the same place. So if we just copy and paste these over here, they will work as long as these numbers are correct. So all we have to do is get these numbers from our data. So this is going to equal a count. And it's the sample 1, so it's everything in K. So we do the K colon K to give us the entire column and not just, the first 15, because if our next set is longer, it's going to mess things up. Then we want to do the same thing for the average, right? Equals the average of everything in that column. Equals the standard deviation of a sample of everything in that column. And then repeat it for the second column, right? Equals the count of everything in the L column. Equals the average of everything in the L column, and then equals standard deviation of a sample of everything in the L column. You can see that when you click the letter L, it just gives you L colon L, which tells Excel take everything in that column. And it's smart enough to ignore anything that's not a number, so it's going to ignore those two things. Now to do all this, like I said, the easiest thing to do is just Control C, Control V, and there you have it. You get the exact same answer because you have the same stats from this set of data. Okay, so that's how we can do confidence intervals with two independent means. Thanks for watching.